Tangam Parvati. Today I am here to have my seminar on the topic 5G technology and its impact on communication under the guidance of Dr. Thompson Davis, the Assistant Professor of Electronics and Communication Department of SJC Pali. Here we will be discussing about what is a wireless communication in the introduction part. Then we will be discussing about the history till 5G network and some of the features, applications, the advantages and disadvantages, the antennas that has been used for 5G technology, then some of its challenges. Then we will be discussing about the technologies behind 5G as well as the companies which are working on 5G. Then the impact of 5G on communication part. Actually, it's about the positive impact side. Then we'll be discussing about its future scope, then the conclusion and reference. As we know that wireless communication is one of the rapidly developing technologies in the world today, and it has been used for a wide range of applications, including mobile phones, in smartphones, laptops, then used for Wi-Fi, Bluetooth networks, etc. New technologies have developed that promises to make this wireless technology much faster, reliable, and more secure. The 5G, it is a fifth generation cellular network technology. This technology was introduced, which promises to offer much faster speeds, low latency compared to the current cellular networks. And this supports many new applications such as augmented reality, virtual reality, self-driving cars, etc. Evolution. Actually, the evolution of mobile technology is a remarkable journey because transforming from a small communication simple communication system to a multifunctional tool. In the year 1979, the 1G technology come into existence with a speed of 2.4 kb per second and has a bandwidth of 10 megahertz. During this technology, only analog communication was possible. I mean, analog voice calls were only available. Then, in the year 1991, the 2G technology comes to existence with a speed of 64 kb per second and a bandwidth of 25 megahertz. And this was the era of digital voice communication. And 2G and 2.5G and 2.75G are the incremental updates of 2G technology. In the year 2001, the 3G technology came into existence with a speed of 2 MB per second and a bandwidth of 100 megahertz. The 3.5 and 3.75G are the incremental upgrades of 3G technology. In 2009, the 4G technology came into existence with bandwidth of 100 megahertz and a speed of 10 to 100 MB per second. And finally, in the year 2019, the 5G technology came into existence with a speed of 1 to 10 GB per second and a bandwidth of sub 6 Hz. The sub 6 Hz means the bandwidth having a frequency which is below 6 GB, 6 gigahertz. Then the 6G technology, which has been expected to be finished or developed completely in the year 2030, and it is expected to have a speed of 1 TB per second. And this technology will mainly focus on the augmented and virtual reality. 1G technology, as we have said that it was introduced in the year 1979, it was operational by the Nippon Telephone and Telegraph in Japan. It has a frequency of 800 to 900 megahertz and a bandwidth of 10 megahertz. Then the modulation which is used for 1G is FM, and the access technique that is being used is FDMA. And we know that 1G technology is an analog technology, so the phone which is using it has a poor battery life as well as low voice quality, and it is has only a little security, so it is prone to drop calls. So in order to overcome this, the 2G technology come into existence. 2G was developed in the late 1980s and was completed in 1990s, and this give an introduction to a new digital technology for wireless transmission, and it is known as the GSM, that is the Global System for Communication. It has a frequency about 900 to 1800 megahertz, and the access technique which has been used is TDMA and CDMA. TDMA for the GSM communication, and the 2G mobile headset batteries that have last longer because of the radio signals having low power. And this technology has been used. This technology provides services like SMS, email, etc. 2.5 and 2.75G. These are the incremental upgrades of 2G technology, and these were developed to provide faster data rates and a better support for the mobile internet access. This 2.5G was based on GPRS, that is the General Packet Radio Service Standard, and this GPRS provide a rate of 57.6 kb per second, which is significantly faster than 9.6 kb second data rates. That is only possible for the 2G network. Then the 2.75G that has been based on the EDGE standard. EDGE stands for the Enhanced Data Rates for GSM Evolution Standard. Actually, the 2.5 and 2.75G was introduced as an incremental upgrade, but they are not formally defined as a wireless standard. 3G technology. 3G was introduced in 2001, which aimed for facilitating a greater voice and data capacity, and it has a wide range of other applications, such as it can be applied for wireless voice calls, mobile network access, video calls, a fixed wireless internet access, then the mobile TV technologies, etc. This technology has a frequency range of 1.8 to 2.5 gigahertz, and the access technique which is being used for 3G is WCDMA. 3.5 and 3.75G. These were designed to provide better performance than 3G systems and as a step towards the deployment for a full 4G capability. And the 3.75G system is an improved version of the 3G network with HSPA+. Actually, the 3.5 technology is based on HSDPA, that is a high-speed download packet access standard, and 3.75G is based on the HSUPA, that is high-speed uplink packet access standard. 4G technology. It was publicly available in 2019 after being unveiled in Stockholm and Oslo. This technology is defined by the International Telecommunication Union as a mobile broadband standard, and this has a frequency of 2 to 8 gigahertz. The access technique that is being used for 4G is OFDMA, that is the orthogonal frequency division multiple access. Actually, Fuji LTE, we used to say Fuji as 4G LTE, which stands for fourth generation long-term evolution. Volt LTE, VoLTE is an improved and more refined version of this 4G LTE. Then there comes the 5G technology. Actually, this was introduced in order to offer a significantly faster data rate, lower latency, greater capacity compared to the previous generation cellular technologies. And it has a lower latency, which is less than 1 millisecond. And it uses millimeter waves for its data transmissions. Then it has high security and is reliable network. The main base or the access technique that is used for 5G is the NOVA, that is a non-orthogonal multiple access. Increase the speed. 5G technology offers a high data transfer rate compared to the previous generation technologies, and with a peak speed reaching up to 10 gigabits per second. Emerging technology. This is one of expected to be the key enabler for the emerging technologies such as autonomous vehicle, augmented reality, virtual reality, as we have said, then the industrial automation, telemedicine, etc. And the and the greatest feature is the low latency, as we have said, as we have mentioned in the few slides before. It is expected to have a latency of 1 millisecond or less, and it is significantly lower than the 4G LTE network, which is about 20 to 30 ms. Then it's high capacity. It provides a capacity of 1 million devices per square kilometer, and also allows more devices to get connected to internet, including a billion of devices to be a part of the IoT. These are some of the applications of 5G technology. It is being used in augmented reality and virtual reality, as we mentioned, then can be used for smart cities and homes, then for precision agriculture, education, telemedicine, then for the remote surgery, disaster relief. It can be used for disaster relief as well as environmental monitoring, etc. These are some of the advantages. All these advantages had been mentioned in the before slides, but let's discuss some of the few new topics. It is being used as it has a low latency, as we said, which is less than 1 millisecond, and it has a reliability of 99.999%, which means that out of 1 lakh data has been if 1 lakh data has been transmitted through a channel, only a 0.001% of error could occur in 5G technology. Then the capacity, that is 1 million devices per square kilometer. It has also a spectral efficiency of 10 to 20 bits per second per hertz. The security, it has an end-to-end encryption security, and it has been used for enhanced mobile broadband. This mainly focus on the augmented as well as the virtual reality part. Some of the disadvantages, it has a cost which is more it has a cost which is around 1.5 lakhs crore, and it is because the 5G users request more cell towers and other infrastructure for its deployment. So the deployment is more expensive and is very difficult to maintain compared to the previous generation networks. It has a coverage of 1.6 to 5 kilometers, and which is very shorter range and and has a less coverage when compared to the previous generation networks. As 4G having something about 3 to 7 kilometers. Then the power consumption. 4G devices consume more power compared to previous cellular network devices, and this is because 4G requires more power for its transmission part. Security. It is vulnerable to new security threats because new technologies like network slicing gets introduced. So it introduces a new security risk for 5G technology. Then the complexity. It is very complex to manage as well as to operate compared to previous technologies, as more complex technology like massive MIMO, beamforming, etc. has been used under the 5G networks. These are some of the antenna technologies used in 5G. Massive MIMO antennas. That is, massive MIMO stands for actually multiple input, multiple output. That is, massive MIMO technology uses a large number of antenna elements to transmit and receive multiple data simultaneously. Then about the beamforming antennas, they focus on the radio signals for in a specific direction. These also transmit large number of antennas to in a single direction. This improves the coverage and performance of individual devices. Then the millimeter wave antennas. These operate extremely in high frequencies, potentially above 100 gigahertz, and has provide a low rate data rates and low latency. Some of the challenges, there are both technical as well as non-technical challenges for 5G technology. As These challenges, they may be similar to the disadvantages of 5G technology. Deployment cost, as we know that it is very expensive to deploy and maintain compared to previous technologies, as it requires more cellular towers and infrastructure. Then the coverage, it has a shorter range compared to previous technologies. Then the power consumption is more, as it requires more power for the power transmission. Security also, it is prone to security threats, as the data is valuable. The valuable data targets for attackers, and if it is compromised, it would have serious consequence for the users as well as the businesses. Then spectrum allocation. It requires more spectrum than previous technologies. It currently allocated to other users such as broadcasters, satellite operators, etc. Negotiations and allocating spectrums for 5G is a complex and time-consuming process too. Regulatory compliance. It is complete with a variety of regulations. We know that, for example, 5G technology must not interfere with other radio frequencies such as aircraft, satellites, etc. Obtaining all the necessary regulatory approvals for the 5G network can be actually complex as well as time-consuming process. Then the public acceptance. The public is concerned about the potential health of 5G radiation. This is one of the non-technical challenge that faced by 5G, and these concerns must have been addressed in order to ensure the public acceptance of 5G technology. These are some of the technologies which are used behind 5G. The new radio or the ENA. It is a new air interface for 5G. This is designed for a more efficient and flexible LTE air interface used in which has been used in 4G. Beamforming is a technique that focuses on signals from a base station to a specific device. This actually improves the signal strength and reduces the interference. Massive MIMO is actually used antennas for the transmit, and it transmits as well as receives data simultaneously. This allows more data to be transmitted and received, and it also improves the coverage as well as the reliability of the network. Network slicing is another technique which allows a single physical layer to be divided into multiple virtual networks, and this network operates to provide different levels of services to different types of users. And the technology is edge computing, which brings data processing closer to where the data is being generated. This can reduce latency and also improve the performance of the applications. These are some of the companies which are working on 5G technology. Some of the companies are Samsung, Huawei, Nokia, Ericsson, Qualcomm, Intel, MediaTek, Broadcom in then the Marvel Technology Group Limited, NVDA Corporations, Cisco, ZTE, etc. Impact of 5G technology on communication. These are some of the positive impacts on communication part. It increases the speed as well as the bandwidth. We know that it has significantly offers a faster speed as well as greater bandwidth compared to other previous technologies. So it enables new services such as high definition like video streaming, AR, VR, etc. Then the reduced latency. This reduced latency compared to the previous cellular technologies also enable new applications like real-time gaming, remote surgeries, etc. Then the increased capacity uh, enables new applications like smart cities, IoT, etc. Also the improved reliability. It has more improved reliability compared to the previous cellular networks, and this make them ideal for the application that requires high reliability such as self-driving cars, critical infrastructure, etc. These are some of the future scope of 5G technologies. It can be used for future as well as we can include advancement in the existing technologies too for its benefits. It can be used for IoT expansion, then industrial and automation applications. The main feature or the scope is on the AR and VR, that is in the augmented reality as well as in the virtual reality. It can be used for smart cities and infrastructure, then used for telemedicine, remote health, then remote surgeries. Also can be used for education, transportation, etc. Conclusion. Actually, the 5G technology significantly has a significantly improvement over the previous generation technologies, offering a faster speed, low latency, and greater capacity. The full potential of 5G is not yet realized, but it is clear that the 5G is a transformative technology that will have a major impact on today's world as well as on the society. It is expected to be enabled for new applications as well as services in the wider range industries. It is used as a catalyst for the new era of communication, promising a world where connectivity is not just a fact, and but also the intelligent and it promises on the intelligent as well as the transformative side. These are some of the references that I have used for this presentation. Thank you.